Okay, let's dive right in. You hear the term AI constantly, right? I mean, it's easily the biggest buzzword of the decade, practically inescapable in tech headlines, earnings calls, and basically your daily news cycle. But today, we're cutting through all that noise and the sci-fi hype. We're going to break down the actual mechanics of artificial intelligence, the different tiers of its evolution, and the very real tangible impact it's having on our world right now. Welcome to The Explainer.
So, quick question for you. Have you ever asked Siri or Alexa to play your favorite song? Well, if you have, you already know you're interacting with AI every single day. Whether you're asking Siri to queue up a playlist while you're driving, having Alexa set a quick timer while you cook, or just relying on your phone's GPS to reroute you around traffic, AI isn't just some distant, futuristic concept waiting for us in the next century. It's actively living on your kitchen counter, it's integrated right into your car, and it's sitting there in your pocket, learning your preferences and habits as we speak.
So the crucial point is, what are we actually dealing with under the hood? At its core, artificial intelligence rests on three main pillars. First up, computer science. That's the fundamental architecture and the algorithms. Second, massive, practically unfathomable oceans of data or information. And third, the ability to problem solve. It's really the synthesis of taking these immense amounts of raw information and using highly sophisticated algorithms to figure out solutions or to execute complex tasks that historically would absolutely require human brainpower and intuition.
Now, we see those three pillars applied across a massive spectrum today, largely driving a total revolution in automation. On one end of things, you have everyday customer service, right? Think chatbots using natural language processing, voice recognition, and machine learning to instantly resolve an issue with your online order. But then, look at the extreme end of the spectrum. Robotics engineering. We're relying on AI to delicately mix toxic, highly volatile chemicals in research labs, or to calculate the exact split-second physics needed to successfully land a multi-billion-dollar space rover millions of miles away on Mars.
Here's the thing, though. Everything we just discussed, from your smart speaker ordering groceries to that wildly complex Mars rover, falls into the exact same category: artificial narrow intelligence, or AII. This is the absolute reality of our tech today, and it's called narrow because it operates strictly within the boundaries it was explicitly trained for. You know, it is incredibly brilliant and efficient at its specific job, but it simply doesn't think outside of that programmed box. A chess-playing AI can absolutely destroy a grandmaster for sure, but it can't tell you how to bake a cake.
Let's move to and see how this builds. The next evolutionary step is artificial general intelligence, or AGI. This is essentially the holy grail for current developers and researchers. AGI represents a level where a computer system can actually reason, plan, and make dynamic decisions across multiple, completely different domains, exactly like a human being would. Now, while a lot of experts believe this highly adaptable human-like intelligence is the inevitable direction we're headed, it's absolutely crucial to note we aren't there quite yet. This is very much tomorrow's frontier.
And then there's the third tier, artificial superintelligence, or ASI. This is the scenario where computer intelligence doesn't just mimic us, but actually surpasses human cognitive abilities across the board. It sounds exactly like the plot of every sci-fi thriller, right? An entity infinitely smarter than its creators. But rest assured, ASI is a purely theoretical concept right now. It's a fascinating and, maybe slightly terrifying wild idea of how far this technology could eventually evolve if AGI is successfully achieved and then allowed to just improve upon itself.
Now, what's really interesting about this slide is looking at the real-world integration of AI as it stands today, because the objective benefits are just undeniable. It streamlines repetitive tasks, handing us back countless hours of our lives to focus on higher-level thinking. It drastically lowers human error in critical calculations, and it accelerates the pace of new technological and medical discoveries. But perhaps its absolute most profound benefit is physical safety, literally keeping human beings out of hazardous environments, whether that's a toxic chemical spill, deep-sea exploration, or bomb defusal, is a massive, life-saving win for our society.
However, this level of rapid advancement comes with a massive price tag. Transitioning into the drawbacks, the sheer execution cost of AI is frankly staggering. We are talking about millions, actually, scratch that, billions upon billions of dollars. The physical infrastructure, the relentless cutting-edge research, and the immense specialized computing power required to train and keep these large language models and neural networks running are astonishingly expensive. It is a massive, massive barrier to entry.
And that financial expense, that's really just the tip of the iceberg. There's the looming potential of job displacement as automation inevitably takes over non-hazardous white-collar roles. Then there's the severe environmental toll. Training a single major AI model can consume more energy than a dozen households use in an entire year, severely draining both power and massive amounts of fresh water just for server cooling. Add in the complex risks of plagiarized art, deepfakes, and heightened automated cybersecurity threats from hackers, and you have a very, very heavy ledger of costs to weigh.
So, considering everything we've covered, let's do a quick rapid-fire review to address a common misconception that pops up in sensationalized headlines all the time. Ready? True or false? As of today, ASI, artificial superintelligence, is purely theoretical. It's remarkably easy for people to conflate the highly capable AI they use at work with the sentient superintelligence they see in blockbuster movies, assuming the machines are already outsmarting us.
The answer is true. Despite all the immense hype and the very real breakthroughs in machine learning, artificial superintelligence remains entirely theoretical. It is not our current reality, and we are still quite a ways off from having to grapple with a machine that is fundamentally smarter than humanity.
Okay, let's keep the momentum going. Instead of sci-fi, we have to ground ourselves in what we are actually using right now. So, fill in the blank. Currently, the AI technology we use is an example of ANI, which stands for Artificial Blank Intelligence. Think about the customer service bots, social media algorithms, or advanced image generators.
Narrow. Artificial narrow intelligence. It is confined entirely to the specific automated tasks it was engineered to solve. Like we said earlier, it's putting the pieces of a very specific puzzle together, brilliantly and flawlessly, but it simply cannot jump to a different puzzle on its own.
So, as we look at the big picture, balancing this ledger becomes a deeply personal and societal exercise. Challenge yourself for a second. Can you name one pro and one con of AI use? What stands out more to you? Is it the undeniable triumph of keeping humans out of dangerous jobs and accelerating medical research, or is it the massive environmental strain of the server farms making it all happen? The friction between the incredible convenience it offers and the very real economic and security risks it poses is huge.
Regardless of how you weigh those pros and cons, one truth is absolutely certain. AI is permanently woven into the fabric of our future. So the ultimate question isn't whether we're going to use it, but how. Now that you understand the mechanics, the distinct limitations, and the heavy consequences, the challenge falls to us. Will we be the generation that figures out how to harness this immense power, ethically, safely, and responsibly? That is the fascinating challenge ahead. Thanks so much for joining me for this explainer.